Welcome to Pavitra Laptop Care. See, here is a HP laptop OP5D. In this, what will be the adapter ID? In Dell, we can say it's a 3 volts approximate, or sometimes that also won't be there. But in HP, exactly how we'll find out adapter ID? Any guess? Some of them will tell it's 1.8, some of them will tell 3 volts, 0.8, or some other things. How it will differ in HP? Why it's not constant? In Dell 3 volts, but in HP it will vary. Why? So today's topic is why adapter ID will change in HP. Okay. One thing I'll show you. So based on that, you can check your adapter ID, what it will be. So I will take an example of this particular schematic. What is that? It's OP5D. It's a Quanta. So let us open the schematic. It's one of my students only. I'll open. So here is the supply where you will find in DC jack. Here is the DC jack 45 watt to 90 watt. So this is main supply, and here is the adapter ID. Where it's going to 47 page. Here nothing is showing, right? What will be the voltage then? AD underscore ID. Here is a resistor that's given to supply. Sorry, it's a diode, and here we will check AD underscore ID. Find, I'll type AD underscore ID. Here 2, total 2, 3. Okay. So one more. Yes. Adapter type check. See, this is most important adapter type check in HP. How you will check? Okay. Here is a component, it's not there, change to current loss, something is given. Okay, here adapter ID continues from 81 page. Okay, here through that 100 ohms resistor, it will come here, and again, is there any voltage divider here? Here is the adapter ID. Okay, here if you consider it's a R1 and R2, then some voltage will be here. Okay, leave it. So again we'll go forward. Again one more resistor is there. Resistor, after this resistor, what is this? Here is a diode. Okay, we will consider this one is 3 volts. Then what will be the voltage divider here? Now what I have to do? Here we will consider it's a 3.3 volts. If we are considering it's a voltage divider, then what voltage we will get here? Okay, I will open voltage divider. Here is the source 3.3. Okay, R1, what it will be? R1 is the 100 ohms. 100 ohms. We will put 100 ohms. Next, R2. 7.15K. Okay, 7.15K, 7.15 kilo ohms. 3.254. See, after crossing this, if you consider it is a voltage divider, then we will get 3. What is that? 254. Is it true? Adapter type, see here ADID is converting as adapter type after this 2K. Okay, it will come here, but adapter type, where it will go? So here we are unable to copy. It will go to where type. Here is the IO, correct? So that information is going to IO pin number 67 as an input. Let us consider this area has 3.2 volts. But is it true Are you getting exactly the adapter type is 3.2? I never seen 3 volts. Means in sometimes I have seen in case of issues will be there no in that condition. But exactly that 3.2 volts is available or not in this path. Please put it in comment. So for technicians I'm telling who have observed adapter ID has come 3.2. Please put it in comment. Now one thing I wanted to clear here, in this path we have a diode. What is this? This is Zener diode. Okay, Zener diode has PD 5.6B something, some name is there, 4704. Correct. So what it is actually, this diode, why they have given? In case if you remove this, what will happen? Those things we will discuss. Okay. See, usually adapter ID path will come. Just assume it's a 3 volts. Here already we saw, 3.3 volts, 3.2 volts. It will come through here. But what exact ID will go to the I/O? That practically I will show you. Here is a diode. What it does? Why they have given here? Why it has connected to the ground? See, Zener diode always will be working in reverse bias. If voltage comes here, it will pass through the ground. In case what the sufficient voltage will come, no, till the time it will pass this path. In case maximum voltage will come, that voltage goes to the ground. How and what voltage? Let us see. See, as we calculated here, 3.2 volts is the maximum voltage is coming here. But what about this? PDZ 5.6B means what? So here is the logic actually. This you need to check. Why they have given 5.6. Okay, I will open the Google. We will go to search. No, it's a Chrome. What is it? It's a PDZ 5.6B. Okay, what it indicates? PD 5.6B. Here 5.6. What is that? PD? Exactly I typed or not? PDZ. Sorry, it's not PD. PDZ. Typed. Some result has come. Now I am opening the data sheet for this. Okay, this one 52874. 52874. That, what is it? Download 10656. 10656. Oh, it's already downloaded. Okay, some sites are not open. Okay, anyway, so I'll come back here itself. I'll check. See, here is the PDZB series voltage regulator diodes. What it does in second page, voltage regulator diode PDZ-B, but we searched it's a 5.6B. Okay, inside it may be there. Here some types are there here. What is that? PDZ 2.4, 2.7, 3, 3.3, 3.6, 3.9, 4.3, 4.7. What is ours? 5.1, 5.6B. Okay, the marking code is Z9. Maybe on the diode here you may get Z9. Okay, marking. Okay, marking is okay. What will be the voltage? Next page. I mean to say here, because of this Zener diode. What Zener diode we have? It's not constant because here the PDZ is 5.6B. See, sometimes some technicians what they will do, they will remove this and they will put from the scrap board, but not exact scrap board, right? They may put some other value. So please concentrate on this particular value. because just now we have seen the voltage value is 1 volts for this. Okay, see up to here it's a 2 volts, no it's not required, it's a 1 volts, same thing only you have to put. Okay, that is the one point you have to be noted down here. So second point, how it will work, how you will get 0.9 volts here, that I will show you. See here something is there, using the circuit I will show you. Here is a Zener diode. Just 1 volt supply I will give, and what it will react, it actually 10.8, but ours is 1 volts, that also I will take. Just we will check in 1 volts how it will work. 1 volt supply I have given. Here what happened here 1 volts, here also 1 volts, here also 1 volts we are getting, correct. So now this diode value what we have 5.6 means it's a 1 volts, right? So this value will change. Here 5.B means it's a 1 volts. Any changes will happen? Oh, 1 volts. See, I put the Zener diode here, it started working. Means here is the maximum 1 volts value. But output we are getting 815. Some losses will be there. Okay, I'll reduce the voltage. This is okay, this is fixed. The main voltage I'll reduce here. 1 volts. If I reduce the voltage, what will happen? See, supply is going here. Here 980, 812. Okay, below 800 I will do. Exactly 750 or 745 again. What's happening? Below 1 volts, what are there? That voltage is available here. Okay, 500 milliamps I'll give. 500 milliamps across this 10k ohms. 500 you are getting, even output also 500. But Zener, it's a 1 volts. But you are below the 1 volts, what are the voltages are there? Same voltage you are getting here. Okay. The main concept is the main supply is below this Zener diode, that output we are getting, right? So this voltage, the main supply voltage, I will increase to 1 volts. What will happen? See here, the circuit is completed here. The electrons started flowing here. Now I am going to increase this supply to what? 1 volts. Now what will happen? Here 823, 778 you are getting. Okay, it's increasing to 1 volts. 1 volt supply, then also it's passing because it's 1 volts capacity is there. Then what about if I increase this 1 volts to 2 volts? Now it's a 2 volts. What will happen? Alright, same thing. 862 millivolts is the maximum one. Here power supply 2 volts came. Okay, 3.2 were there, right? So here what was there? Here according to this voltage divider 3.2 we saw. So that one we'll check. 3.2. What happened? The main source is 3.21, but here we are getting the same output. Okay, 1 volt Zener diode will give it's a 0.8 volts output. Even though before this resistor you have more voltage, then also it will give the constant voltage. It's like a voltage stabilizer or voltage regulator. See here 1 volts regulator voltage Zener diode if you put, so what are the voltage will come? That one will get dropped to ground. Okay, so constantly you will get the voltage of 881, means below 1 volts or below this value volts Zener diodes. Okay, so according to this, okay, I will give 20 volts, then what will happen? That also we will check. See, I will give, usually adapter will be 20 volts, right? 20 volts. 20 volts I have given. So what's happening here? Even though 20 volts, the output will be the same below 1 volts. Now you got my point, right? So the Zener diode will work as per their values. Okay, that's the reason here you have to decide what voltage you are getting here. See, according to this, in generally I have informed you, as per this 1 volts will appear here. Actually 2.5 volts is there, no, that is the internal resistor value, that is not a point. So main thing is 1 volts Zener diode, this one. So here you are getting zero point 0.8 to 0.9 volts. Okay, that's for sure. This is how you will get adapter type in HP. Okay, it's not like Dell directly some using that circuits, so it will get 3 volts or not. But in HP laptops it will vary according to the Zener diode. Not only in adapter type, wherever it has used, according to this value only the value will change. Okay, the below of this value only we are getting. Now you understood, right? The Zener diode will work like this. That's it. Thank you very much.